In this lecture, I will discuss about sampling. So to find things out about a population of interest, it is common practice to take a sample. So a sample is a selection of objects and observations taken from the population of interest. So an important aspect of randomizing possible confounding variables is taking random samples of a population. So population in the statistical sense is different from a biological population of individuals. So it represents all the possible measurements of a particular variable. So a random sample is one in which all members of a population have an equal probability of being sampled. So once you've designed your experiment to control as many confounding variable as possible, okay, so what you need to do, you need to randomize your sample to make sure that they don't differ in the confounding variables that you can control. Okay, so in a random sample, so each individual has an equal probability of being sampled. So for instance, to get a random sample of 50 oil palm trees from a plantation with 700 oil palm trees, this is hypothetical, okay? You should figure out how to sample. So you need to be careful to make sure that your sample is truly random. So this is the keyword for doing the sample, or the first thing that you need to do when you do sampling is make sure that in your mind your sample will be random. For example, so a population might be all durians in an orchard at a given time. So what you want to do, we wish to know how big the durians are. So people will say, oh, this big durian is very big, this one is quite small. So how we want to know it's very big? Of course, we can't measure all of them. So we need to take a sample of some of them and we measure them. So probably we'll take, for instance, here we take one durian here, one durian there, one durian, three durians. Yeah, we take three durians and then we measure and then get the average. Then we can find, oh, this is durian is this big, this big, this big. Okay. However, the method chosen for taking the samples depends on the nature of the population and the resources available in terms of time, effort, and also most of the time is about your money. It's about the financial status, financial capability to do the survey, to do the sampling. The ideal is for each object in a population to be equally likely to be chosen as part of the sample. So this is called an unbiased sample. It is also desirable for the sample to be representative of the population. So you need to know you must be unbiased, that's the first keyword, and the sample must be representative. You want to look at you want to sample how big the Musang Kings are, don't put the D24 inside there. Don't put IOI durian inside there. Okay, you just focus on the Musang King. So which means that you must be representative of the population. So if the population of durians were two-thirds Musang King and one-third D24, the sample should be similarly split. It must split between the D24 and also Musang King. This is the rules of thumbs in sampling. So note that no matter we do, there will always be sampling error or variation due to sampling, as we are looking at a part of the population, not the whole population. We're not doing the census, we're doing sampling. We just pick here and there. So the keyword here is sample. Okay, okay. You can pause here if you need to rewind and rewatch what I already mentioned. So there are two categories of random sampling. First is the probability sampling, and another one is non-probability sampling. In non-probability samples, it's where the element have no chance of being selected. In non-probability samples, it is involved the selections. It is involved the selection of elements based on assumption regarding the population of interest, which forms criteria for selection. So, for example, when you want to do a survey, like a public survey, and when you want to visit every household on a given street or a given uh, park, taman, or even and interview the first person to answer the door in any household with more than one occupant. Okay, this is a non-probability sample because some people are most likely to answer the door during the day. Yeah, you do the survey during the daytime, during the office hour. So you want to see that who's inside in this neighborhood, right? You want to look at this neighborhood, and then you want to see that of who's the you want to interview the first person who opened the door. Oh, this is a non-probability sampling. So, but you might say that, oh, person that you interview must probably the unemployed person, the one who probably students, right? Probably mothers, housewife that at home taking care of kids. So, but it's rarely for you to sample to put into your sampling an engineer, for instance, a government servant, for instance, because they are not they are go working, right? So that's the problem when you do the the non-probability sampling. So you should in but in non-probability samplings is just for your information. So this includes what you call as convenience sampling, what you call as quota sampling, judgment sampling, and also snowballing. You may pause this video and read the text, but basically convenience sampling is like whoever comes to you, right? A quota sampling is something like you want to look at a certain particular people. So you have a certain demographic that you want to choose. You want to look or certain. You want to survey the Malays, only the Malays. You want to survey only the Chinese or only the Indians, only the international students, for instance. So that's a quota sampling. And then judgment sampling is basically you want to look at or you want to sample certain particular lecturers. So this is a very in-depth study. And then also snowballing is a kind of like you want to do the survey, you want to do the sampling based on the person that recommended by the first person. So I want to choose first person, and then the other one will recommend another, the one will recommend another. That's the snowballing for non-probability sampling. But in biostatistics, the most sampling techniques approach that we always do is what we call as probability sampling. So there are few types of this sampling basically. So first, what we call as a random sample. A simple random sample is theoretically the ideal method of sampling. You list each member of the population and use random numbers to decide which objects are in the sample. So each object is equally likely to be selected. Okay. So basically, this produces an unbiased sample which we hope is representative. However, it can be difficult and expensive to take simple random sample when dealing with people. Okay, simple random sampling is more practical when the population is geographically concentrated and when a good sampling frame exists. So, a sampling frame is a list of all the people or objects in the population interest. So, simple random sampling can be more easily implemented for natural and for manufacturing populations. Okay, I'll give you some examples later on. So, but simple random sampling can easily be done by automatic generation. You want to find you want to randomly pick people, pick numbers, you can use your scientific calculator. You can look at the lecture notes on how you can do this with your own scientific calculator. But myself, I like to use whatever you have in the computer. Yeah, Microsoft Excel has a good ways to generate uh, uh, sampling random numbers. Okay, or you can use traditionally or classically using a random number tables. I will show you how to use the random number tables in this lecture. So you can use these statistical tables. You can go. I already. You can find this in the library. In fact, in this course, if we do when you do the final exam, you will use these statistical tables a lot. Okay, for this course. So you can refer to your table 37, random numbers number one at page 54 from these statistical tables books. Okay, you can also Google it, but most of random number tables available online are single digit, while in this book is a double digit random number table. So how it looks like, almost like this. Okay, so let me open it a little bit. Okay, so how to use a random table? So first of all, here is a random table. So this is table 37, random numbers number one. What is the purpose of the table? So so we, here here we can you can pick random numbers, right? So well, if you make up numbers in your head, they are not always random. Okay, no matter how hard you try. So this is the purpose of using it. So if let's say if you are a Cristiano Ronaldo, number 7 will pop up frequently. Okay, so just joking. So what is this? The table is used to give you a list of random numbers. These numbers could be used for various reasons. They could be actual numbers, or they could represent other data. Okay, so for instance, let's say we try this one. Let's stimulate this event. Okay, let's use this table to stimulate an event. So here we want to random. Let's say you want to pick up 20 students from 700. So if you don't use numbers, you will be just pick the best friends that you have, the closest friend, the 20 closest friend, the closest 20 to you, and then you will be a bias. And then this is not a random, but you need to pick 20 people in a random. So it's only really random if every one of the 700 has a chance of being picked. First, we can number our participants. We can number this all 700 participants with numbers. So from 1 to 700. So we give every people like a lucky draw. Okay, I give you numbers. Okay, this is your lucky number. Okay, and then but we need to be fair, lah. So everybody have their one. So the first number, let's say I have number 1, you have number 2. My number will be 001, 002, 003, and we'll go up to 700. Okay, so first we pick up a random we first we pick a random starting point in the table. Okay, like here, then we create 3-digit numbers following the tables. So for instance, let me change here a little to my laser point. Oops. Okay, so go straight. First, let's say you want to choose a random number, the 3-digit numbers. Okay, so let's say you start from here. So you can close your eyes and then go around, and then you start, and then you want to pick here. So you can start and then go to the right. Okay, so first 3-digit number will be 169. So 169 is within 1 to 700, right? So your first number will 169. So then this is will be your first number, 169. The second one will be 555. So this is 555. So the second lucky number will be 555. So you can go on 679. Okay, so 671, sorry, okay, I have my problem with my mouse. So 671 will be the third number. Okay, but the fourth number is 998. So 998 is beyond the 700. So we will exclude 998. So the next number will be 105. Next number will 171. The next number will be 751. Okay, sorry. The 751 is beyond the number, so you exclude the 751. Oh, sorry, my mouse is making a problem here. So the next is 286. So 735, 805, 807, 443, and so on and so forth until you get all the 20 numbers. Okay, that's how you use the random numbers. So basically, then now you can try this. Say you try to find a number between just five number between 100 and 1000 using the random number table. Okay, good luck. Uh, Next is what we call as systematic sampling. Okay, it's a systematic sampling. With systematic sampling, you want to choose a starting point at random. So you have a system to choose a uh, a random number, or how you want to sample randomly. You can use systematically. So you can choose a starting random point. Okay, for instance, I want to start from here. Okay, and then systematically take objects at certain number apart. For example, if there are 1,000 in the population and you want to sample of 50, you would take every 20th objects. So systematic samples are easier to administer than simple random samples and are usually a good approximation of a random sample. However, if there is a pattern in the population, certain types of object could be chosen more or less often than others. So for instance, for instance, you can start from this person, and then you want to choose every five. That's your system. You want to choose every five person after this person. So you want to choose every one, two, three, four, and five. So you want to choose this gentleman here. This is your uh, first sample. So this is five. So we get one, two, three, four, and five. This is another five. The second one, two, three, four, and five. This is another one. So and then you can continue and then choose 20 of them. So you can choose a one, two, three, four, and five. So you have this one, two, three, four, and five. So you have a system where you can choose your sample. So this is what we call as the systematic sampling. So as long as you go on in this course or in this program or in biostatistics, you will find out there's tons of a lot of other ways to do a systematic sampling. So another technique, what you call as a cluster sampling. Excuse me, the sampling is usually used for the heterogeneous population which cannot be predicted. Okay, so you can sample all the individuals from several subunits which have randomly have chosen. You already chose from a certain particular part. So for instance, to determine the biomass in forest are very heterogeneous and clustered. Few have a very high biomass, others have very low biomass. So the method that usually used is what you call as quadrat sampling. But and in cluster sampling, the population is divided first. Okay, they're divided into clusters, which are then chosen to random. Uh, so this provide sample units not identified independently, but in group or clusters. So you already first of all you cluster them. So you have a section 1, section 2, section 3, section 4, and also section 5. So you divided them into 5 sections. But then you randomly pick which section that you want to sample. So you chose from a random number that from 1 to 5, then you chose section 1 and section 5. So you only survey for this whole population only the 4 houses in section 4, 4 houses in section 5. Why we did this cluster? Because of the demography, or because of the geographical areas. For instance, this area has more abundance, but this area is a little bit small, but this area is uh, have river, have lakes, probably have different types of population, probably not many people inside here. Let's say there is in section 5 there is a forest, there are 3 forests inside here, so you need to be a little bit uh, you want to include that also. If you do the random sampling here, probably you not include this kind of population, but again you need to sample. So that's why you cluster them first accordingly, uh, and then you pick up the first 2 areas. This always be done in any surveys. uh, let's say whole population is already divided into groups. So one two in random sample will be taken of these group clusters. Within each clusters, all of the objects are included in the sample. So random sample of these units. Okay, so first divided them first, and then you chose the uh, areas that you want to include it. Okay, cluster sampling can be more convenient and practical than simple random sampling. However, if the clusters are different from each other with regards to the elements we are measuring, it can lead to biased or non-biased representatives. Okay, so you need to be mindful when you do the clustering. Okay, you can pause first here and then rewind, and then if you want to relook or rewatch what I already discussed. So next is what we call as stratified sampling. Okay, stratified sampling seems like cluster sampling, but the strata or groups are chosen specifically to represent different characteristics within the population, such as types, variety, ethnicity, location, age or occupation, or what else. Okay, within each group, a random sample is taken, sometimes in proportion to the size of the group. So let's say you have different types of apples. You have yellow apples, green apples, red apples, orange apples. So you stratify them first. Okay, you differentiate them first, and then you want to okay, I want to pick 5 random yellow apples, 5 random green apples, 5 random red apples, 5 randoms orange apples. So these are the way to do the stratified sampling. So stratified sampling can lead to a very good random representative samples. However, it can be complex to administer. So you need to stratify them first, right? And a simple and a sampling frame with considerable information about the population is required. You need to know the population first, okay, before you do the stratification. So the other sampling, there are also some other sampling methods. The methods explained here only give an idea of the advantages and disadvantages of various methods. You should attempt, well, when you do your final project, or you want to do your research later on, you should attempt to use a sampling method that produces the best results for the resources you have available. Okay, you need to look at your time, how much time, how the time window that you have, and then how much that you need to do, the effort that you need to, how big, how can you do. Well, personally, you need to, do you need a team? And also you need to look at your financial status, because sometimes so people don't want to survey unless you pay them, right? Okay, you complete the survey, I'll give you KFC voucher, for instance. So that also need to be done. So it depends on your capability. You need to look at these factors also. Okay, the time, the effort, and also the financial status. So, and finally, if your sample has known bias, remember, sample must be unbiased. So if you have known bias, let's say I want to only sample my friends only. Sorry. Okay. I want to sample my friends only. Then the problem will be, so you have a problem to do the proper sampling. Again, you need to be not biased. There is no bias in your sampling. Okay. Until next time. Bye.